Everybody knew about it. Nobody really knew what we were doing. So this was pretty cool. The ice is then put into these trays. Once we dry it, we put it into insulated shipping boxes and we pile a whole bunch of snow in here. It's cheap packing material. We stack them onto wood skids, put them onto Air Force pallets, cover them up with blankets, put them on the airplane, put them into a shipping container. And here's where we skip. The shipping container gets put onto a ship, but somebody else is talking about logistics, so I'm skipping to what we do here.
Can we ask a question about the...
Yeah.
So this facility, that's basically the only way to drill the ice core, right?
Yes.
So you need to have multiple facilities like that in Antarctica, in Greenland, to be able to actually get the ice core? Because you're only drilling in one location.
Correct. We're only drilling in one location, and it takes us 3 to 5 years to get a single core from the surface all the way to bedrock. So we're going up and down the same borehole, getting deeper and deeper and deeper. Sometimes we have multiples, but not of the big drills. Generally, when a big operation is going, we only have one big operation going. What I just showed you was from Waste Divide. Waste Divide is about an $80 million project. So no, they don't fund more than one of those. There's a lot of people that are upset when we start running big coring operations because they're probably shorting funding from other NSF projects. Once the ice arrives here, sorry, I'm blocking you guys. Tell me if I'm blocking you guys, will you? I should start it up.
So I was curious, so how long does it take to go to get to bedrock?
3 to 5 years.
3 to 5 years.
If everything is working properly, we can do roughly 1,000 meters a year. It's really cold, it's sort of complex, and almost nothing works properly all the time. At Waste Divide, we burned up 3 motors. They had 3 motors. We burned up 4 control systems. We had 4 control systems. And there was an engineer who was staying up 2 and 3 nights in a row, swapping parts in and out to get a controller to work again. So it was, you do what you have to keep things going.
And that's just from drilling December, January?
Yes.
Okay.
So everybody works really hard to get as much core as we possibly can in a season. And it turns out you can actually get things shipped to Antarctica relatively quickly. I got something down to a field camp in 4 days once. These guys, when they were shipping parts in for the drill, took them a week. So it's surprisingly fast. FedEx is wonderful down to Christchurch. And then if they know what's going on, they can put things on planes and get things hop, skip, and jump it out to your site. So it's amazingly fast. So this is 1,440 meters of ice core waiting to be unpacked. That's the entire storage aisle that I have, completely full. It's about 50 feet front to back. We load it up onto the shelves, and then we start cutting. This is one of our specialties. Aside from keeping the place safe and cold, we process core. This would be a CPL. This is kind of what you guys are going to be doing today. Long before we start drilling, they figure out what everybody needs. You got people who do chemistry. This is a chemistry slab. You got people who do isotopes. That's an isotope slab. The people who do physical properties periodically get a slab here for a vertical. They also get what we call a horizontal. So they get a slice this way. Their horizontal slice is about 1 centimeter thick, and this is probably about 1/2 centimeter thick. They glue that to glass, shape it down, look at it under cross-polarized lenses. We cut these slabs on a horizontal bandsaw. You get to see it. Somebody gets to drive it. This slab goes over to a saw line for isotopes where we cut the sticks out. This slab goes over to the chemistry line where we cut a stick out. They cut this one out. The rest of the core, the green line is a planer line. We run it under a horizontal planer, flatten it out. It goes through electroconductivity machine, goes through high resolution imaging, goes through physical properties where a guy describes it, and then it goes over to the gas station and we start chopping blocks out of here. Didn't know that was in there. This is what it takes to get it done. So this is horizontal bandsaw slabs. Slabs go to chemistry, isotopes. The main core goes around the room, ends up over here in the gas station, and then all of this stuff gets bagged up and packed up, put back into storage. See if this is going to work. Going to go? Yay! We remeasure everything that comes in from the field. It's cold down there, they don't always get it right, and especially for brittle ice, it's almost impossible to get it completely correct. So we line it all up, we remeasure it, we cut the slabs. This is just to show it's cold. We pull them off into special boxes. They go to the saw lines, where they get unpacked and run through the saws. Each of the saw lines has two saws, one to rip the edge, the other to rip the sample. This is what you're going to be doing, not that. Low res, they break it in half and put it into a bottle. We plane it, very noisy. ECM is not there, so we have a bypass track. But he's electrocuting the ice. By electrocuting the ice, you can tell the annual layers. Summer layers conduct better than winter layers, so you end up with a nice annual signal. If it's nice ice, you can actually see something, and we take high resolution images. Physical properties, this is brittle ice. He describes the ice, writes it down in a meter-long logbook. These are the bubbles that everybody wants to see. It's showing the gas. We're getting ready to chop blocks. There's 3 guys that do gas analysis, and they're 10 centimeters each. We cut a 30 centimeter block, wing it, cut the blocks. Each block then goes off to the proper principal investigator. We repack, put it into storage, and guard it. Label, label, label. If I don't have labels on stuff, I don't know what I got. So we label the bags, we label the ice, we label it in the database. We got 2 databases actually that have all of the information. The blue packs that you saw in there, that's how we ship FedEx. Blue packs melt at minus 10F, so they will keep the package below minus 20C, which is about minus 10F, it turns out. And we ship priority overnight, so it's supposed to get there by 10:30 the next day, assuming it doesn't get stuck in Memphis. So all of you guys are talking about climate after this, so I'm not going to go into climate.
Yeah, because that'll be covered big time.
What else do you want to know? We can do questions now. I'm way ahead of schedule. Yes.
I had a question from the last, actually it was kind of from the last talk.
Uh-oh.
But I didn't really understand, he mentioned the various ways, information what we get from the ice core. And I was trying to figure out, I understand the gas, and how you get information of greenhouse gas stuff. How do you get temperature, do you get direct temperature change information, or is that just inferred?
It's a proxy.
Okay.
Temperature we derive from the difference between 016 and 018. It turns out for any given temperature, you have a ratio of the light oxygen compared to the heavy oxygen. The warmer it is, the more 018. So in the tropics, moisture goes off into the atmosphere at some ratio. As it gets cooler and the water with the isotopes in it starts to rain, the cooler it is, the more the rain Yeah, what else am I supposed to talk about? I was gonna talk about my database, but,
No, you're fine.
Okay.
I just plugged in and you're okay. No, you're
Oh,
fine.
cool.
Just to say though, tomorrow they're gonna go into that breakdown,
okay,
because we'll be at the isotope lab where they do that.
oh, good.
So,
But
yeah.
the easy explanation is the colder it gets, the faster the O18 rains out, the lighter the isotopes as it continues over South Pole. At South Pole, you have very light water, and that's not the right way of saying it because it means something different. It's light isotopically.